We're good to go. Again, if anybody has any questions, just send them in the chat, and someone will either let me know to address it, or I will give a little bit of a break after I finish this presentation and go over a couple of questions. And so today we're going to be going back over a little bit, some refresher. We have some files that we had saved previously. We got our bathymetry data sets together. We put in the coverages into the map module and set those up. Then we generated a quad tree grid. And so that's showing up here in the data tree. And so all of this has previously been saved, and it's in a folder on the day 3 material. Probably it says, I think it's webinar. So you can just load that at some point and you'll be caught up with where I am right now. We did go over the boundary conditions yesterday, and I didn't realize that it was actually in today. So you're going to be able to get a little refresher on that as well right now. So you see the quad tree now shows up as a U-grid instead of a Cartesian hybrid type of grid. That's just a new thing they've added into SMS 13.2 and 3. And basically this is where they're moving pretty much all of their grids to this unstructured grid format. It can be, some rules can be applied to this grid to enforce different things. So basically we've got some rules in place on how this quad tree grid can exist and what the neighbors need to be and look like. And they are still adding in some of the old tools that used to be available for Cartesian and other types of grids. Used to be, there are a few different options if you right click on the grid, and there's very few right now, but we're getting those back in there, and hopefully eventually all those tools will make it back in there. So let's just move on. This is showing creating the activity classification. So we went over how to finish off this polygon. You left. So actually what we're talking about right now is we can, in the newest interface, sorry, we can now turn off land cells. And how you do this is to select that activity classification, choose the select polygon and make sure you select it. And then you can right click on it and tell it to select intersecting objects. So right now we're working in the map module, and what we're wanting to do is select all of the U-grid cells that are contained within that polygon. So that's what we're doing here, select intersecting objects. And you have multiple different things that you can choose to select, but in our case, we're going to keep it as U-grid and make sure this says cells, because there is an option for points. But we want to always use cells with CMS. So select those cells. You can try a few different boundaries here, but in my running this, pretty much all of them give the same thing. You might miss 1 or 2 cells with one of them, but it's not a big change between these different options there. Once you make sure you have the U-grid and the cells selected, you would come over here and click whatever is showing, but what we're going to make sure we do is select the quad tree generator. There may be other things here. Make sure you select the right one, then click OK. It selects the cells, and then you have the capability to turn them on or off. You might need to right click after the cells come back as selected and then choose turn on or off, something like that. We'll go over it in the demo and I'll show you how to do this. And then you just change that to off, and now all your land cells are gone. So this has been something we've missed since the SMS 11.2 days, where we didn't have to worry about visualizing and seeing all these land cells. And I'm glad to have that back. just know that they are still there. They're just hidden. And if you ever need to access one or two of those cells, maybe to expand your um, selections or to change some values or anything like that, you'll need to turn those back on, and then you'll be able to access that. So I'll show a little bit of that later on in the demo. So now we're going to go into boundary conditions. You saw it yesterday, but we're going to choose it again today. So essentially, boundary conditions are how we force the CMS model with different types of processes. And so the main ones we typically use are an offshore boundary, which I've defined here. So it's in the map module. Just select the boundary conditions. You choose the Create Arc tool, and then you just create an arc outside of the area that you're interested in. It doesn't have to be perfect. You can always change it later, and I'll show a tool that we've developed to make sure that you can see which cells are going to be assigned to that boundary condition. And if you need to lengthen some arcs or change them, you can always do that later. But in this case, we have chosen to just do 3 points on the outside edge here to force our open boundary for the offshore edge. And as soon as you do that, it comes in as unassigned. And then we'll go in and a few other steps here and actually change that to be some type of forcing. I'm referencing a river in this image, but this particular case has no rivers that we used in the project. But I will show how to create one a little bit later on, so that you can use that in the future in your particular grid. So, all right. So now that that arc has been selected, has been created, you would change your tools to select the arc, or you could actually use this global select tool and then choose that. And you can either double click on it or right click and choose assign boundary conditions. Either way, it brings up a option to define that boundary condition for the selected arc or arcs. And so we're going to change this type to be water surface elevation forcing for our offshore edge. And then there are several different options under water source elevation source or water surface elevation source. But we're going to choose define the curve. And that basically allows us to vary our forcing through time. Otherwise, it would be a constant. So anyway, under define curve, we click this box and it brings up our editor here with a box for the time and a column for the water surface elevation. You can hand enter these if you want to, or what I typically do is open a spreadsheet, grab a couple of columns, cut and then paste it right here back into the editor. And then once it's in there, you'll see a representation of that curve over here. If you already have a file that's created for you, that's in a format that SMS can read, you can import. So there's a button here at the bottom for import, and then go out and find that file. In our case, I've got that file. It's called water level forcing.xys, and it's under day 2, CMS grid creation. So you can select that, click open, and then it brings in the data. And then we have that over here showing on the right. Once you get out of that, you can give it a name. You can change some other values, like for the offset or the sea level change that you might want to implement, and also make the choices for what's going on with salinity or temperature for that particular boundary condition. We're not really going to talk about those today, but we can discuss one-on-one later if you have any questions. For the river flux, it's basically the same thing. You would click a couple of an arc that covers a couple of cells. Click on that arc and choose flow rate forcing for the type instead of water surface elevation. And then you have a few options here for a constant or for a curve. We're going to choose curve, and then you'll see that it's basically the same exact interface. The only difference is this description here. It is flow, and this is in meters cubed per second. And that's for the total for that arc and not per cell like it used to be in previous versions of SMS. So we're now providing the total flow for that exact arc, and then CMS will divide that up among the cells. And so again, you could import or you could enter the values, you could cut and paste, whatever you'd like to do. We don't have any files for this course, so I'm not going to really go into it. There are other types of boundary conditions. There's tidal and harmonic, and I kind of got into this yesterday about what the differences are. But essentially, the harmonic has no association with time, and it doesn't have any predefined constituents. You would have to provide the speed and amplitude and phase instead of just the amplitude and phase for that particular constituent. I also went into the tidal database forcing with external tides. And so that's basically, you would change this water surface elevation source. You would change that down to external tidal. And then you get a note here saying that the tidal constituents come from a component in the simulation. And I'll show that in a few minutes. I think I showed it yesterday, but it's relatively easy to set up. And then you can still make any changes that you need to. So when you have all your boundary conditions defined, you have your activity classification defined, you have your quad tree built, what we need to do is combine all of those together in a simulation. And to do that, we right click in this area, open area in the project data tree, and choose new simulation. And so something like this, not quite as big, will show up, and you just choose new simulation, and you have several choices. This is an old list. The new SMS 13 has maybe 13 or 15 different models that they've gone ahead and added now. But for our case, we're going to choose CMS-Flow. And when you do that, it pops a new simulation here. And you can change the name of this if you want. By default, everything comes in as just sim. But it might be nice if you have multiple of these simulations, maybe one for an existing case, one for an alternative, or whatever, to name them so that you can keep them separate. And so how do you get the different information assigned to that simulation? So each one of these, if you right click on them, there's an apply option, and you would apply it to that simulation. And then they would show under here. If it's not under this simulation and you go to run, it's not going to do anything. It doesn't know what the grid looks like or anything like that. So everything needs to come in under these simulations that are at the bottom of this data tree. Additionally, when we were working with that tidal constituent, we said it would come in as a different component in the simulation. So we can click here under new simulation. There's an option for tidal constituents. Once we click that, it adds a new tidal constituent simulation. And then we can apply that to the grid as well, like we did with the others. And it shows up there. Without that, it will not have any tidal forcing coming from those tidal databases. And so when to actually get the constituents and everything defined, you would right click on this sim and tell it to edit those constituents. You get a dialog that looks like this, and then you can change the source to be one of any of these types. We're going to choose AdCirc 2015 for most of our grids because that's in the United States and it's been resolved. Again, there's several versions in the past of this. but the newest grid is rather large and it has a lot of extra cells that the previous ones did not. And so your availability of coverage is better with that. Le Prevost is good if you're working anywhere else on the globe. And this, just to let you know, this is the older Le Prevost title database option. They have some new ones, this FES 2014, and I want to say there's a newer one than that. Those are actually proprietary. You have to pay for those data files. SMS does not provide those for you, but if you have them on your own, then you can choose that option and then hand edit the file locations for those files. The same thing goes for this TPXO 8 and 9 or any other user-defined type of data set. But in our case, we're going to choose AdCirc 2015. Just note that each one of these title databases have a different number of constituents that are available to it. And so you may or may not have the same options between them. For AdCirc, I think it's 30 something different constituents you can choose. For the most part, depending on where you are in the country, some of these constituents have a larger influence than others. And you can look at the harmonic constituents maybe on the Know What Tides and Currents page or some other resource that might provide that information and look at those constituents for that area and pick and choose the ones that have the greatest influence, which would mean the highest amplitude. If you want to just select some major constituents, you can click that. And then it would select, I think, 5 of these, which are typically the larger for most of the country. If you select minor, then I think it's a selection of 8 different constituents, and you can even add more if you'd like. And once you've selected those, just click OK, you come back, and they're ready to go. For the rest of this demo, though, we're not going to show that because I'm not using tides for this particular simulation, so you will not see that again. We can go over it if you have questions later on, but the rest of this is going to be for just a water surface elevation forcing on the open offshore. So when you're getting ready to run with CMS, there are different data sets that you're going to need. One of those is a bottom friction for all of your ocean and different active computational area. And so you'll have bottom friction, and that can come in either Manning's or a roughness type of formulation. We typically use Manning's, but there are 3 options that you have available to you. If you're running with sediment transport turned on, then you would probably want to define a bed layer. And in that bed layer, you have the option to define different percentiles of grain sizes that make up that bed. And so those would come in as data sets. Additionally, there's a hard bottom designation that is for a couple of different parts of the United States. In Hawaii and Florida, there's several areas where there may be areas below the sediment that limit at a certain point, and you're not able to erode below those. It's been compacted and it's almost concrete down there beyond a certain point. And so we've identified those, and you can change this hard bottom to enable that layer. And then once you get down to that layer, you will not be able to erode anymore. We also use this for different structures like jetties or bridge pilings and things like that. And so there may be occasion to use it even if you don't have that other information about a layer underneath the sediment. You can still turn it on so you don't get erosion over your jetties if they're overtopped or what have you. So lots of different applications for that. I'm going into different numbers here. The bottom friction we typically use in CMS, this 0.025. But if you have a number, a Manning's number, that you want to use for your area that you've calculated. You're able to choose whatever value you want, and I'll show how that's done in a few minutes. Same thing for the sediment percentile. Every different area has a different mean grain size that's being moved. And so you may want to choose the different numbers depending on your area. For hard bottom, we typically by default give a value of -999, and that's just a flag saying that every cell in the grid is freely erodible. And then we can come back later on, select cells, and limit those particular cells to a certain depth. And all that is done with the dataset toolbox, the dataset calculator here, and I'm going to show how to do that. So under data, you would select dataset toolbox. This comes up, and then you choose data calculator. And as we showed for the datum conversions, you have different values here. You'll need to add these values to the calculator window, make some value here. You don't necessarily have to equate them to an existing value. You can actually put just 0.025 here for the bottom friction, and that will assign a default value of that to every cell. So that's what this shows. You put in 0.025, you give it a name, Manning's in our case. Then you hit compute and done. And then you can move on and create one of these other data sets. You notice when we do come in here, since we're in the U-grid and we have both cells and nodes, it says, which do you want to map it to? We always select cells. And I'm trying to get them to find a way to get rid of nodes when we are working in a CMS type space, just so people don't get confused. We had a user come to us not long ago that had Manning set with nodes, and when they mapped it to the CMS grid, everything worked, it ran, but the nodes were placed oddly, and so they ended up with increased flow in areas that they didn't want. So make sure you do select cells every time. And then it pops up here, and we can work on the other ones. And so here we're putting in a 0.26 for a D50, and then we put in a -999 for a hard bottom. I'm creating these all at one time. You can do this later once you get into model control if you want, but I find it easier to go ahead and create these first, and then they're already there so that we can link right to them once we get to the model control. Okay, so how do you get to the model control? Used to, there were options up here on the toolbar for CMS-Flow. All the models were up here. You would select those and choose any tools that you wanted, but we're not running all that model specific stuff has been pulled out of these toolbars, and it's now available in the data tree and as part of the simulation. So in our case, to get to the model control, we will right click on Sim down here in our CMS-Flow simulation. Well, actually we renamed it to SRI Test Run 1. But we would right click on that and choose model control. There's several different things here, and I'm not going to get into all of these today. But if we have questions or if we have time, I might go in and give a little bit of an explanation of some of this. But for this, we're going to choose the model control, which pulls up this window, and there's several different tabs for different types of processes. So it looks a little bit different than what it used to in SMS 11.0 or whatever, but this is what we're using now. We've tried to group these a little bit better and remove some that we actually wanted the users never to touch unless they're an expert. And so we have ways to get those back in. But for the most part, these are the ones that you'll be working with. So we have general, which covers all of this information. There's starting date and time, how long are we going to run, what kind of a ramp duration do we want. Just quickly, I'll explain the ramp. When you first start, a run, all the water is level in your grid. And so if you start with an initial strong forcing, then you can get instabilities and divergence in the model. And so we add this ramp duration so that in this period of time, the forcing for the model is limited down to 0 and gradually increased over that window. And so in this case, we have 24-hour window. And so by the time you make it back to 24 hours, you're at full forcing for all of the different things that are going on in your particular case. Some different options down here. There's a hot start option. I can't remember if these are on by default, but it's always good to turn this on. I use the recurring hot start file all the time. So just get in a habit of turning this on, maybe writing it out every hour, every 2 hours, whatever you want. If something happens while you're running and your computer dies or you run out of disk space or whatever, you're able to come back later after those problems have been resolved and choose a hot start that you previously wrote out as an initial conditions file to start as a hot start. And so it's always nice to have. We're not going to go into this as part of this course, but we can give some explanation later on one-on-one if you'd like. I mentioned in the first day that we had different solution schemes, implicit and explicit. You can make this choice here, choose which solver you use. Typically, I always use the same solver, whether it's the implicit or explicit. And then if needed, we can change these to get a little bit different behavior. Maybe one would converge a little bit easier in certain situations, but we've not really found guidance for that yet. Threads is the number of processors that you want to use for the CMS-Flow. If you're running implicit, really the maximum that you need is or can use is 4. You could specify more, but it's not going to speed anything up. It might actually slow things down if you get more than that. So in our case, we're changing the starting time to January 1st of 2001. We're going to run for 744 hours with a 24-hour ramp. Writing out a single hot start file after 2 days, but then also a different file we're writing out every half hour. We're going to be using 4 threads. I don't remember if this goes into all of them. Yes, it does. Okay, so there's a flow tab where we specify, okay, what's the time step going to be? What is our wetting and drying depth? And this you'll change depending on where you are. So you might get better results if you change this to 0.1 or 0.12 or something like that. And this is basically the depth, the amount of water that has to be in a cell. If it's less than that, then CMS sees that as a dry cell and does not include it in further computations until the conditions are such that it re-wets. Couple of options for wave fluxes and roller fluxes. Where do we get our Coriolis from? Bottom friction. Normally I leave all of this the same. You might turn on bed slope friction. Wall friction is always on. But here's where you want to select and choose that bottom friction data set that we chose or created earlier. And so this Manning's in, if you click that, there's a couple of different options, but we're using Manning's. We'll choose this data set, and then it brings this dialog. We choose which one, and then it gets assigned, and we can move on to the next tab. So by default, sediment transport is off. You can turn that on. You get a lot of options available to you. I'll go through a couple of these. The morphology change start time. Essentially, this says don't change any of your bed until after this amount of time has passed. And typically we use this because we don't necessarily want to start our sediment transport stuff going on until after the ramp. And that way, when we start comparing with observations or whatever, we're back to full forcing and we can understand what's going on. So we normally use this to limit the morphology change during that REM period. You can choose different formulations. By default, we have this, we call this the net, but it's non-equilibrium total load formulation. And you can change these to guide, how the sediment is actually moved through the suspended part of the water column. Some properties of the sediment: density and porosity here you can change if you want. Typically, we leave these the same. And then as you get down, you have grain size definitions, and you can choose how many layers that you're going to represent. By default, it always has one. You can choose, if you define this, you notice up here the maximum number of bed layers is set to 10 by default. When CMS needs additional layers, it will create new layers up to this 10. This is just providing information about how it is initially set up as far as the types of grain sizes. And so as you see, as we scroll across on each layer line containing the bed layers, you have the different sediment percentiles that you can specify for that particular area. So we set up a D50 earlier layer that was 0.026, I think, or 0.26 millimeters. And so you click none here, and then you can define, okay, which of these data sets we're going to choose this one. And then it goes in and assigns that, and then you can go through and set any of the other options as well. As you move down, then you get to the grain sizes. And so here, by default, we don't have any grain sizes loaded. You would click this plus and add one, and then enter what your grain size that you want to actually follow as you're moving through the suspended part of the column. So before all of this, the bed layer stuff is just what's in the bed and below. And then these are actually what's suspended in the water column and moved around. It may settle out and go into the bed, but this is the grain sizes that we're defining for what we're actually moving around in the suspended part of the water column. You need at least one, but you can have multiple. Just be aware that for each different grain size, it adds additional computation time for every grain size that you're moving around, because it has all of that it has to keep track of and separate. Typically, we use 1 to 3 different grain sizes. I rarely use anything more than that. It's possible we may have used 5 in the past, but for the most part, we typically use around between 1 and 3. There's an avalanching, and I briefly mentioned that the other day, but basically as the sediment is moving around and changing the shape, you may end up with sediment placed on a taller slope, which in reality that would start falling back down and settling. And so the avalanching allows us to go through and let that happen over some number of iterations. At one point, we didn't have this limit to the iterations, and it would get in infinite loops because it'd be moving it back and forth, and we had some trouble there. So we've placed a limit of 100 iterations now. You can specify what that angle of repose is. And then there's also the hard bottom. You can turn that on and then define what that hard bottom data set is. And then there's a few other tabs here. We're going to go over the wave tab later when we get to the steering part. I'm not going to cover the salinity or temperature. We can go over the wind, although this particular run that we have set up for you guys does not use the wind. And then there is output. And so by default, we start every grid with, or every simulation with starting at 0, ending after 30 days with an increment of 1 hour. And then we also, by default, turn on a couple of different data sets, just so there's something being written out. At some point in the past, people would forget to turn this on. They'd go through a week-long simulation, and then there was zero output because they had forgotten to turn it on. So we want to make sure that you guys have something to look at, but we do request that you go into this tab, change it to exactly the time frame that you need, turn on different pieces of information that you may need, whether it be morphology, sediment transport rates, eddy viscosity, or whatever. So go through and do that. And you can choose different lists. So if you want to see morphology change in a different increment in your output, you can assign a different list to that particular thing. So we have up to 4 that you can choose from and set up. And then that's done over here later. In our case, this particular run is for 744 hours. So that's basically 31 days. And we did change the simulation label. And by default, it just says simulation. And if you're running multiple alternatives, it's always nice to have them labeled differently so you can tell them apart when you load them back in. And for this case, we're changing the increment to be 3 hours on list 2. And then we can set morphology to be that list 2, and we can set transport to be on list 3, or whatever. You can just make whatever choices that you need here. When you're done with everything that you want to provide as input for the model, then you can click OK and come back to the main screen. So earlier I'd mentioned that there's a way for you guys to see which cells are affected by the boundary conditions. And so that is the snap preview. So if you, let me go back to another page here. Sorry. If you right click on this model, there are several different options, and one of them is generate snap preview. And so let me just show what that looks like. So it brings up this list, generate snap preview. It doesn't ask for anything. It just goes out there and does it. And so basically it looks at every boundary condition arc and tries to map that arc to the nearest active computational cell. And so and then it gives you some indication of where that is. This is really useful if you may have some beach area that is computational, but you don't necessarily want to provide the forcing at that area, or when you're looking at rivers, it'll tell you exactly which 3 or 5 cells are going to be forced with that boundary condition information, and then you can make choices on, are those the right 3? Do I need to change the size and shape? Things like that. And so once you have that and everything is ready to go, we've said this several times here, make sure you save often. So I always save the project before I do anything. But then you can right click on the actual simulation that you have set up and choose save the simulation. And this actually exports the CMS files. So what this does is it takes the grid as it is in SMS. And on the first day, you remember me talking about in SMS, all your depths in the ocean, in the deep water, have to be negative. So this step actually changes the sign of that as it's writing it out for CMS. So it writes them out as positive, and we can actually use CMS. And so it writes out all the other files. If you have, you're using a database or title constituents or whatever, it puts all of that information together in the CM cards parameter file and or a series of other files so that you can run CMS. It does go through a model check before it saves these things. And so if there's anything that's obvious that is done incorrectly, it'll stop you, or at least warn you that you may need to change a few things before you actually run. And then you would just choose, after they're written out, you would choose run. You could do all this in one step by choosing this last option. It'll say the project, simulation files, and then run. And then you come up with this run queue. And in this case, we're only running one particular case. As it's running, this bar will progress through. And down here, it actually shows you what would be appearing on the screen if you're running from the command prompt. So this is different information about how well the model is running. So just as an example here, you can tell this is only time step number 5. We are still within the forcing ramp that I have set up for 24 hours. So we're 30 or 0.3% done with that ramp. The DT for this particular time step is 600 seconds, and the elapsed time is 3 to the third number of seconds. The number of active cells in the grid, because we do have wetting and drying, so sometimes you'll have more or less cells. So the number of active cells at this particular time is 37,500 or so. There's information down here about how well the hydrodynamics are being calculated. So you see it's iterating through different attempts to converge on a solution. And so the very first of those, it has a certain convergence rate. These are residual numbers. So the smaller these values, the better. And as you progress through these iterations, it finally gets to something in a negative e to the negative 10 or 8 or whatever, and is able to converge. So at 17, it stops. So this shows every 10 and then the final one, whichever that might be. And I think there's a maximum default setting to be 30 or 29, something like that. So you may see up to that depending on, strong forcing times, things like that. If you're running with sediment, then you will start to get some sediment movement, and these are iterations on what's going on with the sediment. This is just the concentrated, suspended part of that sediment that's moving through the cells. And so this value through time will start increasing as you get stronger and stronger forcing. It's not doing enough here to really move any sediment yet, so you're not seeing anything. We also do have a residual plot that is computed within SMS as you go. It kind of looks at the results of those residuals, and then it plots them so that you can see times when the stress is a little bit higher. And these may be problematic if your model starts to fail or whatever. It's probably during one of these times when that residual number is larger than the default here. And this just gives you an indication of how well it's running through time. So in this particular case, it was around 26% complete. You can see we had already calculated 700,000 seconds. I guess that's about 3 or 4 days, maybe. I can't remember. And then you can close this at some point. If you want to stop it early, you would click abort. But if you don't abort, then it's going to continue until it either dies or it finishes completely. And that is pretty much it as far as running CMS-Flow.